Okay, before we start today, let's just do a little warm up from past ideas just to make sure our brains are fresh. What is the y-intercept and slope for this question? So we want to make sure we're in the right format. So if we take a quick look, are we in y equals mx plus b format? And the answer is yes, we are. So it doesn't matter with the order in terms of the way this is written. We could also move this around. Okay, these two things are exactly the same. So we are in the correct format, so we can say our slope is negative 4 over 1 and our y-intercept is 0, 8. Okay, so left side, right side. Okay, need some flexibility in your thinking, but it's usually nice to have the y on the left side just because we get used to it. Okay, write the equation of the line with a slope of 4 and passing through negative 3, negative 9. So I'm going to do this two ways really quickly. I'll do this by a picture. So negative 3, negative 9 is about here. Okay, so there's my point. And then I'm going to put the placeholder of a 1 underneath that 4. So my slope is 4, 1. So I'm going to go up 4, right 1, up 4, right 1, up 4, right 1, up 4, right 1. Okay, and that's as far as I need to go because really the only piece I wanted was that guy. Okay, so if I take those two pieces of information, my slope is 4 and my y-intercept is 3. There's my equation from the graph. Okay, but let's do it quickly algebraically just so we have that in our minds. We write down the equation of the line. We substitute in our slope. That was step 2. Step 3, we sub in our point, making sure we put our x's and y's in the correct location. Okay, so this becomes negative 9 equals negative 12 plus b. Add 12 to both sides. See if I can fit that in there. Okay, so we add 12 to this becomes 3. And then we finish with y equals 4x plus 3, which is the same answer. So two ways of doing the exact same problem, one with graphs and one with algebra. Both are correct. Okay, so today, by the end of today, I want to be able to recognize parallel and perpendicular lines from their equations. Okay, and there's some properties of parallel and perpendicular lines that we want to recognize. So just for clarity, parallel is like train tracks. You may have seen this in geometry somewhere. They have little arrows to show those are parallel. And perpendicular is when two lines meet at right angles. So those are your definitions. So parallel and perpendicular. Okay, so that's what we're going to be looking at today. So let's get it. Okay, so graph the following three lines. What similarities do you see? So again, whenever I see my equations written in y equals mx plus b format, I just have the habit, I write down their slopes and their y-intercepts right away. So there's my first one. I have a slope of 2, a y-intercept of 7. 7, so if I plot that really quickly, it's up 2 over 1. And then I can work that backwards. Draw my line. There it is. Okay, we'll go to the next one. I have a slope of 2 and a y-intercept of 3. So I put my y-intercept on, up 2 over 1. And, okay, I think I got the idea here. Let's do the last one just for kicks. Now this is in reverse order. It's okay, the y is by itself, so we can deal with that. So our slope is 2. Our y-intercept is negative 6. 2, 4, negative 6, up 2 over 1. And if my drawing skills are moderately good, let's see if I can draw this relatively close. We should see those three lines are all parallel. Okay, and now what is the property that makes them parallel? Well, it's certainly not the y-intercept because the y-intercept is different on all of them. But what we should see is the slope. Slope for all of them was the same. So parallel lines have the same slope. That's all it takes. So when lines have the same slope, we know they're going to be parallel. Okay, so the symbol for parallel is these two little bars. Okay, so parallel lines have the same slope. Take a second, write that down, put that somewhere you can find it again because it's going to be important. Okay, let's go back to the next one now. Graph the following two lines. At what angle do the two lines meet? Now you can probably guess where this is going, but let's take a look. M is 2 over 1, so my slope is 2 over 1. My y-intercept is 0, 3. So if I plot that information, I'm going to put my y-intercept down, go up 2 over 1, up 2 over 1, up 2 over 1. I'll go backwards just so I have a couple more points. And then I'm going to draw a decent line here. Not too bad. Let's switch over to the next one. Now, I got to be careful here. This is a negative slope. And I'm going through a y-intercept of -2. So here's that location. Now, negative slope, that means down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Okay, I can also work that backwards. Okay, and if I draw my line here, it's not too bad. If I grab my protractor, let's see if I can make this work relatively quickly. If I've done a decent job graphing, not too bad, a little off, but by freehand, I can live with it. What we should see is those two lines meet at 90 degrees. Okay, so they intersect at 90 degrees, which means they're perpendicular. Okay, so what property, actually let's bounce back here for a minute. What property, okay, made them perpendicular? Well, there's something a little different here. The y-intercepts are not the same, so it's not that property. And the slopes are not the same, but you should notice something about the slopes. There's a 2 and a 1 there, and there's a 1 and a 2 here. Okay, now one's positive, one's negative, and what we're going to see is something called a negative reciprocal. Okay, so perpendicular lines have slopes that are negative reciprocals of each other. Okay, so the symbol for perpendicular is a little upside down T. So I find it really helpful to put in placeholders. So if I have this slope of 3, this is 3 over 1. Okay, and a quick little test you can do is if you take the original slope and you multiply it by the perpendicular slope, you should always get a -1. So if you do a quick little test here, 3 over 1 times -1 over 3. If we do our fraction multiplication, multiply across the top, multiply across the bottom, hey, I got -1. Okay, so reciprocal is a fancy word for flip. Okay, so you'll notice this is 3 over 1 here. The flip of it would be 1 over 3, but one of them has to be negative. And I'll show you that a little bit more on this one right here. Okay, so find parallel and perpendicular slopes for the following. Again, I'm going to put my placeholder in. So if I want parallel, that's the two little bars right here. Parallel should have the same slope. Perpendicular should have the reciprocal, but because the original slope was positive, the perpendicular slope needs to be negative. Get the idea here? Okay, let's try another one. Okay, I'll change color. The first slope is -3, and I'm going to put in the placeholder. So the parallel slope will be -3 over 1. They'll be the same. Parallel slopes are the same. Okay, now when I go to the perpendicular, the first thing I got to do is flip it. Okay, but now the first one is negative. That means this one is going to be positive. Okay, so when you're dealing with perpendicular slopes, only one of the terms can be negative. Okay, that's really important to pick up. Okay, so now we have a slope of 3/4. So the parallel slope again would be the same. My perpendicular slope would be the reciprocal. But right now, the way they're written on the screen, they're both positive. So I can't have that. So the first one, the original, was positive. That means my perpendicular slope over here has to be negative. Okay, and then lastly, oh, that is lastly, we're good. Okay. All right, so let's put it into action. Find equations. We need the slope and any point. So just a reminder, we need the slope and any point to do this. So find the equation of the line that is perpendicular to y equals -3x plus 8 and passes through 6, 1. And I'm going to do a little literacy issue here. This word right here is really, really important math. Okay, it's really important in literacy too, but in math it means there's an important idea before it and there's an important idea after it. So when you see this one, look for information before it and look for after it. Okay, so if we're looking for information about slopes, okay, so find the equation of the line is perpendicular to, so this dude right here is dealing with slope. Any point passes through this point. Okay, so this is how we're going to do our equations of our lines. We're going to use the algebraic techniques. We're going to write down our equation. Y equals mx plus b. Step 2, sub in the slope. Okay, well, we don't have a slope right yet, but we're going to get one. Okay, so this guy right here, this is my original. Okay, I want to be perpendicular to this. Well, this has a slope of -3/1. Well, what is perpendicular to that? And I would strongly recommend using the notation to tell when things change. I'm using color and symbols. So this guy would become my new slope. So this is the slope I want to use on my next line. Okay, and now I go back to the regular steps. Step 3, sub in the point and solve for b. Well, here's my point. So I'm going to put a y is 1. I'm going to put an x of 6. 1/3 times 6. You can put a placeholder there if you need to. So that becomes multiply across the top is 6. Across the bottom is 3. 6 divided by 3 is 2. We subtract 2 from both sides. And we get -1 equals b, but that's not the equation of a line, that's just the b value, so let's bring it all together. There's the equation of the line that satisfies that criteria. Okay, so we're perpendicular to the highlighted in blue, and we're passing through the point 6,1. And if you want to do a quick test, you should be able to substitute the point 6,1 into this, and it should make a true statement. Okay, we're almost done here. Find the equation of the line that is parallel to this line and has the same x-intercept as this line. Okay, so here's that key word, and I've separated it spatially so we can see there are two ideas. So if you remember, equations of lines need slopes and points. Well, if you read the first part of this sentence, parallel to, well, parallel is immediately talking about slope. So right up here we have slope information. Okay, it's not jumping out or explicitly written, but that is slope information. Okay, down here has the same x-intercept as this line. Well, this is point information. Okay, so we need a slope and we need any point. So there they are, they're just hidden. So now you have to use all of your skills to find those two pieces. Okay, so if you want to pause it and give that a whirl, you can give it a try. Okay, so I'm going to take this. I do not like the standard form, so I'm going to rearrange this expression. Come on, purple ink. So I'm immediately going to subtract 2x from both sides and add 8 to both sides. Okay, I'm then going to divide everything by 4. And I'm going to get my equation written in y equals mx plus b format. Now I don't really need all of that. All I really need is the slope, which is 1/2. Now if I am parallel, then that slope that I'm going to use to solve this expression is 1/2. So I put a box around it so I know what to find. Okay, let's go down here. Has the same x-intercept as this line. Well, let's use our skills we developed already. X-intercepts have a y value of 0. So I take this expression, I put a y value of 0 in there. 4x minus 3 times 0 equals 12. This is 0. 4x equals 12, x equals 3. So the point I need to use is 3, 0. So now, there's my slope, there's my point. I now have enough information to go and find the equation of this line. You You can see how all of this stuff comes together. So y equals mx plus b, sub in my slope, sub in my x-intercept, solve for b. I'm going to run out of room here. Okay, subtract 3 over 2 from both sides, and yes, you can have fractions. It's okay. All right, and then let's write our final equation. Let's do it in purple. So y equals 1/2 x minus 3 over 2. That's the answer to this question. Okay, so you can see how lots of pieces get brought into these questions. Okay, and then lastly, are the following line segments parallel, perpendicular, or neither? Okay, so if we look at line segment AB, what we need to find is the slope. That's the important piece. So if I find the slope of AB, and I can do that relatively quickly, so the slope of AB is 2/3. And now CD, I'll do the same. So the slope of CD, you'll notice I have little subscripts here to give me some idea of which one's which. Watching the double negative here in particular. So -6 plus 2, this is -4. And that becomes 3 over -2. Okay, now if I compare these two here, okay, they're definitely not parallel, okay, because they're not the same. They do have the same numbers. They're flipped. One's positive, one's negative. Therefore, AB is perpendicular to CD. Okay, so there's a couple questions to try. Only if you're up for it, try the super challenging. They're combining a lot of elements, but focus on these ones for now. That would be great. Thanks for tuning in.